Hey, good day, future engineers. Hope all is well, and welcome to our class this day. In this discussion, we'll be tackling about the application of definite integral. So this is a further topic from our previous discussion. Particularly, we'll be talking about the areas of a region between curves. So already slightly, we already touched lightly the areas bounded by the curve in our previous discussions. But right now, we'll be discussing this a little bit more deeply. So, aron masabta na to siya. Kaya let's proceed with our discussion on the application of definite integral. So, how are we gonna get the areas that on the regions between two curves? So may buhaton ninyo ana. 'Di ba in your previous in your lower years, when you have a say, let's say we have a circle. And then, but let's say this is a tube. So how are we gonna get the area in this region? So what we do with this one is just we just subtract the area is just we just subtract the area of the larger circle minus the area of the smaller circle. Wala ba, diba? Or let's say if we have a rectangle or even flanges, diba? Same concept also applies. You can get the area of the whole minus the areas of this part to get the area of this region. Same thing also with the curve. Say we have a graph here, and then we have a curve looking like that, and then there is also a curve going like this. And then we were asked to find this area, this specific region. This is our area of interest. So, unsaon man nato na siya pagkuha. So, let's say this curve here is our f of x, and then this curve here is our g of x. G is a function of x. Now, that is just simply similar to the previous to this how we got the areas of these regions here. So ang mahitabuan na is that kasi we have a curve here. So first is that we get the area of this one, of this region. It is something like this. And then we subtract the area beneath that one. And eventually, we'll be able to get the area of this region. This is the region bounded between two curves. So kung saan man na to siya, how we gonna apply the integration with this one? So for this one, di ba, we just for the first one, let's say we have a differential element here, a vertical differential element, and also same with this one. Its base is the x, and the height is just the y. Same also with this one, the x, and the height is just the y. So the area will just be the integral of this element. We have the base times height, that is the x, times the height, y. But since the y, the upper y here, the y of this curve or the function of this curve is different with the function beneath it, we represent that y as an f of x. Diba? And minus the other one, this one. So that is just the dx times g of x from A to B. So the A and B is our lower and the upper limits respectively. So that is the A, and then here in this side, this is the B. This is the point of intersection between two curves. So simply speaking, this is just uh, the integral of the y upper minus the y lower dx from A to B. This is if our differential element is vertical. Now, what happens if we have a horizontal nga kuan, differential element? Then, what will happen is like this. Since kung horizontal differential element, we have this one, then we will have our dy on the height, and then we have our x here in the base. So that is just equal to the integral of x x right minus the x left from A to B. So Samani, what are these y and what are these x? The y is a function of x and the x is also a function of y. These are equations and they need to be written with respect to this one. If dy need, then we need to isolate the x on the left side and isolate y on the right side. If the x ang atong required here, ato ang object of the derivative differentiation, then for our y, we isolate y on the left side, and then we will have our x on the right side. So on the horizontal differential element, example po na is like this. No, let's say we have a curve like this, and then bounded by this one. So we need to use a horizontal differential element with that one. So same concept also with this one here. Murag po na siya our upper limit, that is x right. The right one here is this one, so we have the x right. And then to be subtracted by the curve bounded on this left side minus this one. Then eventually we will get the area of the region bounded by these two curves also here. So we have a figure shown here, no, para mas ma-elaborate, para mas masabtan yun na to. It just shows here that the area of this region is just equal to the area of this one bounded by the upper curve minus the area of this one bounded by the lower curve. Again, that is just equal to the integral of y upper minus the y lower dx from A to B. This is if our differential element is vertical, like in this case or scenario. Now, if our differential element is vertical, again, just remember that that is the x right minus the x left dy from A to B. Or A to B is our lower and upper limit. So, we can, let's proceed to our first example. Aron mas masabtan nato siya. So here we have a region bounded by the graph. So we have a graph y is equal to x squared plus 2, y is equal to negative x is equal to 0, and x is equal to 1. Without looking at the graph on the left side of this presentation, we can see that there is a parabola here that is y is equal to x squared plus 2. And then y is equal to negative x, that is a line. This is a linear because this is a linear equation. And then x is equal to 2 and x is equal to 1. So we have a region here. So first we have a y is equal to x squared plus 2 represented by here. So we have a curve here. This is our given curve. Next we have a line. This one here. For niya, it is also bounded by the x is equal to 0 and x is equal to 1. So at x is equal to 0, this is the line at x is equal to 0. And at x is equal to 1, this will be the boundary also. So obviously we'll be using our vertical strip or vertical differential element in solving the area of these specific regions. Again, that is just equal to the integral of y upper minus y lower dx from A to B. Or if you look closely, see y upper is represented by f of x, and then atong y lower is represented by g of x dx from A to B. So the area bounded by this curve is just equal to the integral. So what is the f of x? That is just the, we have the x squared plus 2. And then minus g of x, or the second y, or the lower, or the y lower, getting represented by the line. So that is negative x dx. Our lower limit, what is our lower limit? Since dx manidiri is auto ang lower and upper limit should be also along the x-axis. So that is 0 and 1 because bora man ni siya ang region nga ato ang i-consider. This is our area of interest. At x is equal to 0 and x is equal to 1. So we just simplify the equation. We have x squared. We will have x squared plus x plus 2 dx from 0 to 1. So na plus x na siya because the negative of a negative is a positive. So the area is just equal to 1/3 x cubed plus 1/2 x squared plus 2x, and to be evaluated from 0 to 1. So at x is equal to 1, we have 1/3 plus 1/2 plus 2 minus 0. So here we got an area of 17/6 square units. Since we don't have an actual unit here, so we just use a unit, and this is a area. That's why we have a square. And then this will be the area of the region bounded by this, or not really bounded, but bounded by the graph of these two curves here. So yan na siya kadali, di ba? Okay, for our next sample, we have here a region bounded by the curve. So now in this one, naa na intersection between two curves. We have a first degree curve that is a linear equation, a line. And the second one, we have a graph. Again, this is a parabola. So, unsa may bato na to ani? In the previous example, we were given an x is equal to 0 and x is equal to 1. And we're able to find that the lower and upper limit is 0 to 1. So, unsa may bato na to with this second example? So we need to get the lower and the upper limit also with this one. Also, the lower and upper limit is that from here, this is our lower limit because this is the negative x na part, and then this will be the upper limit along the x. So saan man nato na siya pagkuha? Say we don't have the graph, and then the graph is not really scaled, no? Not really drawn to scale. Unsa man itong button? We just equate the two equation to get the point of intersections made by the intersection of these two curves. So we will have 2 minus x squared is equal to x. This is that is from here, no? We just equate them. And we will get x squared plus x minus 2 is equal to 0. You factor that out, you will get x plus 2 times x minus 1 is equal to 0. Therefore, the point of intersection of our two curves is at -2 and at +1. So this will be our lower limit. The lower limit will be -2 and our upper limit will be 1. This is the point at which the two curves intersect. Okay, so having written that one, having determined already our lower and upper limit, then we proceed with the getting of our area. So that is just the integral of the upper. So unsa gani formula na to the upper? And that is just the 2 minus x squared minus the lower, so minus x. The x from -2 to 1. Okay, obviously, no, this is just equal to -1/2 x squared, sorry, that is 1/3 x cubed. -1/3 x cubed minus 1/2 x squared plus 2x. And to be evaluated from -2 to 1. So we'll have an area of -1/3 times 1 minus 1/2 times 1 is 1 cube 1 squared. Obviously, that is just 1 plus 2 times 1 minus -1/3 times -2 cube minus 1/2 times -2 squared plus 2 times -2. We'll have an area is equal to, we have here, we have the 7/6 minus -10 over 3. So the area bounded by these two graphs is just equal to 9/2 or 4.5 square units. So this is very easy. You know, you just let's say there is no graph. So in yung button is you graph first the two curves, the two graphs or the two equations that were given to us. And then since we have a parabola here, say there is no drawing, then first you need to determine the vertex of the parabola. So that's why it is important, no, to remember this very basic formula: y plus minus h is equal to a times x plus minus k squared. This is for the parabola. Or x plus minus h is equal to plus minus a times y minus plus minus k squared. This is to determine the vertex of the parabola will then be equal to hk. See, for a third example, we have here the sine and cosine curves intersect infinitely many times, bounding regions of equal curves. Find the area of one of the regions. So here we have a graph showing now the sine curve and the cosine curve. So here this curve here is our sine curve, and the darker one, the darker shade one, and then our lighter shade here, this is our cosine curve, represented by g of x. So here we'll be using the vertical strip, and then we'll need to get this intersection. Then this will be our lower and our upper limit with this one. So since we already have the graph, and our next concern will be determining the lower and the upper limit. So again, saan ka nito pag-determine the lower and the upper limit? We can determine the lower and upper limit if we equate the two equations. So for this one, we just equate f of x with g of x. So that is just equal to sine x is equal to cosine x. And then we will have tangent x is equal to 1 To get x, we just get the inverse, and then finally we will get that our x is equal to pi over 4 and 5 pi over 4 if our x is greater than or equal to 0 but less than or equal to 2 pi. So 0 to 2 pi lang atong limit for the x. Then we'll have our two boundaries or limits for this for the curve sa nga kung asa sila nag-intersect. Again, since this is a trigonometric function, remember to always use radian mode in your calculations. So this is our lower limit. This will be our upper limit. So we just get the area of the curve that is just equal to the integral of y upper again. Okay, this is don't forget this one, y upper minus y lower dx from a to b. So the area is equal to the integral of y upper. Our upper is in this graph. Kani siya ang nasa upper na to is the sine x minus lower na to is the cosine x dx from pi over 4 to 5 pi over 4. So the area is just equal to negative cosine x minus sine x. And to be evaluated from pi over 4 to 5 pi over 4. So this one will lead us to square root of negative 2 for the upper limit minus the lower limit that is negative square root of 2. So the area for the curve is just equal to 2 square root of 2 square units. Okay, so to just summarize, no, if first one, if we don't have a curve, then you draw the graph. Next is that you determine the limits if it's not given. So if the curve intersect, then therefore you can equate the limits. No, you can equate like our previous example that f of x is equal to g of x, or that y1 is equal to y2. And then after determining your upper and lower limits, then you get the area. So that is we will have the y upper minus y lower dx from a to b for the vertical strip, or y a is equal to integral of x right minus x left dy from a to b. Just so you know, if you are curious, no, kung unsa ni y upper and y lower, we just represent it by f of x minus g of x dx from a to b, and the other one we can represent that with f of y minus g of y dy from a to b. And then you already have your answer in square units.